Hello everyone, welcome to our third and final lesson from 5-5, where we have been learning about exponential functions and radicals. And today our focus is going to be on turning an exponential function into a radical. What that means is that we are going to take a term that has a fractional exponent and we are going to put it into a square root. And so if you look up here at the top of your notes, it says a to the power of 1 over n. And when we put it into a square root, we take the numerator and that goes inside the square root symbol with your variable or your term that has the exponent that is a fraction. And then your denominator goes on the outside of your square root symbol, okay? So looking at this one, a to the power of m over n. This term, m, your numerator is going to go on the inside of the square root symbol, and the n, your denominator, goes on the outside, okay? And then let's go ahead and look at our very first example, steps to converting to radical form. Okay, so the very first step says any coefficient that does not have a fractional exponent remains on the outside of the square root symbol, and that's any term. So if you look at this first example here, 10 times c to the power of 4/5. 4/5 is only applied to the c, not to the 10. If it was also applied to the 10, then there would be a 4/5 right behind the 10, or 10 and c would be in parentheses, okay? So we're going to leave the 10 on the outside of the square root symbol. So I'm going to write 10 right here, and then I'm going to write my square root symbol, okay? Then the next part of step 1 says, if you have a coefficient that has a fractional exponent, it goes inside the radical symbol. And you'll see an example of that in a little bit. The variable c will go inside the square root symbol because it has a fractional exponent. So I'm going to put my c on the inside, okay? Your numerator becomes the exponent of your radicand. And I put this up here again. The radicand is the term inside of the radical symbol or the square root symbol. So the numerator becomes the exponent, and the denominator becomes your index. Remember, your index is the term that goes right outside of your radical symbol. So that would be 5. And this first page is all about turning exponential functions into radicals, and that's it. So this first page is going to be pretty simple once you get the hang of where all of the terms go. Looking at example number 1 and following your steps up here, step number 1 is all about a coefficient, and at this point we don't have a coefficient, so we're going to move on to step 2. Step 2 says that the variable will go inside the square root symbol. So I'm going to write a square root symbol and I'm going to put my variable in here. Step 3 says that my numerator becomes my exponent. So my numerator becomes my exponent and my denominator becomes my index. Okay. And that's all you're doing. So go ahead and try example 2, pause the video, and then check to see. Actually, why don't you do examples 2, 3, and 4. Okay, there you have it. What I try to do is I try to find an image in my head of where those numbers will go, where that numerator and denominator will go in the exponent. And so if you have, you can see this, if you have your numerator and your denominator, I imagine a visual of them just moving like this. And so the denominator, which was right here, will go on the index. The numerator will go into the square root as an exponent. Okay, that's just sort of how I remember it. Okay, examples 5 and 6 are very similar to the example that we did up here at the top. Okay, so because my coefficient does not have an exponent to it, it is going to stay on the outside of my radical symbol. And then I'll do that. A has a fractional exponent, so it's going to go inside the square root symbol. My numerator becomes my exponent. My denominator becomes my index. All right, example 6, same process. There you go. Okay, examples 7 and 8 are just slightly different. Notice that you have a term inside of a parentheses with the exponent on the outside. That means that we have to apply the exponent to both terms, and then both of those terms will end up going into your radical symbol. So my very first step is to apply the 2/3 to both terms on the inside. So I have 3 to the power of 2/3, and I have a to the power of 2/3. Now, once you get the hang of how this works, this step right here can be eliminated. This is how I started out when I was learning about these, and then now I can look at the problem and know exactly how to set it up without writing it out like this first. So I'm going to make my square root symbol. My 3 and my a both have the same fractional exponent, so they're both going to go into the same square root. So I have 3 and I have a. My numerator becomes the exponent of both my 2 and my 3, my 3 and my a. So I have a 2 and a 2, so 3 squared, a squared. And then my denominator goes on the outside. Now, at this point, you might say, well, we're done, but I would like for you to simplify these as far as you can. So we can simplify the 3 squared, and we could get a final answer of 9a squared with an index of 3. Okay. All right, same process for example 8 if you want to try it on your own. Okay, there you go. So that was the first half of our set of notes. And so when you look at your homework, I believe you have about 4 or 6 problems that cover this concept right here. Okay, moving on to page 2. This time, what we're going to do is we are going to go ahead and put them into a radical, but we're going to simplify them. So we're going to use concepts that we learned from lessons 1 through 4 and part of 5 to be able to simplify these radicals as far as they can go. So let's start with this example, 64r, okay, and both of those are raised to the power of 2/3. And so let's go along and follow the steps. Apply the exponent to all terms within the parentheses by rewriting the problem. Remember, the 5 is the index. Oh, I need to change this, and I'll change this before I give it to you. The 3 is the index, and the 2 represents the exponent that will be applied to both the 64 and the r. So basically what we just did in examples 7 and 8. Okay, so we have 64 to the power of 2/3 and r to the power of 2/3. Okay. Simplify your coefficient that is raised to a fractional exponent by using a factor tree. Okay, before I do that though, I am going to put it into a radical. So we have 64 squared r squared with an index of 3. Now I'm going to do step 2. And so I'm going to use a factor tree for 64. Now notice here that 64 is squared. So whatever numbers we end up with when we're done factoring, we have to double those, okay? So I will take 8 times 8, 2 times 4, 2 times 4. Okay, so here I have 1, 2, 3, 4, 5, 6 2s. Okay, so there's different ways that you could do this. You could go ahead and write out all 12 2s, which a lot of people end up doing just to help eliminate mistakes. Or you can know that in this group, you have 2 groups of 3, which means you're going to end up with 4 groups of 3 because you had to square that 64. Okay, so I'm going to go ahead and this is going to be, this is a lot more work. If you could do it in your head, that's fine. This is one of those things where you can. So I'm going to go ahead and write out all my 2s. One, 2, 3, 4, 5, 6, and then I have 2 r's. Okay. Now, if you remember from our previous lesson, we now need to, and this is with an index of 3, we now need to circle groups of 3. So I have 1, 2, 3, 4. Okay, so then I would rewrite that as 2 times 2 times 2 times 2. And I have 2 r's left over, so r times r. And then I can simplify that. 2 times 2 is 4, times 2 is 8, times 2 is 16. R times r is r squared, not 2r. R plus r is 2r, but r times r is r squared, okay, with an index of 3. So we have simplified this down to as far as we can. So 64r raised to the power of 2/3 is 16, index of 3, and then r squared, just like that. Okay. And so these problems can take a little bit of time. We have 6 examples here, and you can use this page on most of your assignment. Okay. So the first 2 examples, I chose kind of a tricky one here, so we can cover everything that could possibly happen when you're simplifying these terms. So examples 9 and 10 are pretty simple. We're going to apply the exponent to both terms inside of the parentheses. So 25 to the power of 1/2, a to the power of 1/2. And then we're going to put that into a radical, 25a, and the exponent is 1, but we don't have to write 1 as the exponent. We just know that it's there. And then 2 would be your index, but a square root already assumes that that is a 2. So you can write those numbers if you would like, but you don't have to. Okay. So now I'm going to go to step 2, simplify my coefficient. And so this coefficient right here, I can square it. I can use a factor tree. And we have one group of 5. And then the a is by itself. The a does not have a partner to pair up with so that it can move to the outside. Okay. So what this means is that the square root of 25 is 5. We can pull that out of the square root symbol, and the a has to stay inside. And there you have it. Number 10 is very similar to number 9 if you want to try that one on your own. So we have a group of 4 3s, and then we have the b by itself. So we factored everything in there. So now we can pull out the 3, but we have to leave the b. Okay. And don't forget your index, that's really important. That is part of the points when I'm grading your homework. Okay. All right, let's go ahead and go down to example 11, 12. So we have 16 to the power of 2/3 and c to the power of 2/3. And we can rewrite that as 16 squared c squared with an index of 3. So now we're finding groups of 3. So I'm going to use a factor tree to factor out my coefficient of 16. And I get, okay, so, and then we have 2 c's. Okay, so I need groups of 3. I have one group of 3 2's, but I don't have another group of 3. So I can pull this 2 out, and then I leave the rest inside the square root, so, or the radical symbol. And then we have a 2 times c, so your final answer is 2 cube root of 2c squared. All right, example number 12. 36 raised to the power of 3/4, and then x raised to the power of 3/4. So rewriting that as a radical, I have 36 cubed x cubed with an index of 4. Okay, so the next step, we're going to factor out the 36, and when we do that, you're going to find groups of 4, and then you're going to triple that because it's raised to an exponent of 3. So we have 36, 6 and 6, 2, 3, 2, 3. So what this means is that I'm not going to have just 2 2's, I'm going to have 6 2's, because if I were to factor out 36 3 times, I'd end up with 6 2's and 6 3's. So I can write this out like this. Okay, I have 2 times 2. That was my first 36. Another 2 times 2, which was my second 36. And another 2 times 2, which was my third 36. So now I do the same thing with the 3's. 2 3's for my first time, 2 3's for the second time, and 2 3's for the third time that you factored out 36. And then I have 3 x's. Okay, so now I'm going to circle my groups of 4. Okay. And that's it. I just have 2 groups, one group of 2 and one group of 3. So what that means that I will do is I have a 2 times 3 on the outside of the radical. And then I have 2 2's left, 2 3's left, and 3 x's left. Okay. So now I can simplify that. 6, and we have an index of 4. 2 times 2 is 4, times 3 is 12, times 3 is 36. X times x times x is x cubed. And then that is my final answer. Fun. Math is fun. Okay, so let's go ahead and do our final two problems. You might be able to do these on your own now. So I have 81 power 3/2 and x to the power 3/2. Now you may not think that this one is any different, but it is a little bit different just because your numerator is now larger than your denominator. So you're going to be able to pull more out of that radical. Okay, so 81 cubed and x cubed. Now, remember, I'm not going to put my 2 there because I don't need to. We assume it's there. Okay, so now I'm going to factor out my 81. Okay, and I have 4 3s after factoring it out one time. That means I'm going to have a total of 12 3s. And so I'm going to write this down here. And I have 3 x's. Okay, now I will say I have 2 groups of 3 right here. So that would be 9. And then I could take 9 cubed. So I have 3 times 3, which equals 9. And since we're cubing it, since we have 3 of these 81s, I could cube it. So I end up with 9 times 9 times 9, which should give me the same answer as this. 9 times 9 is 81. 81 times 9 is 729. So this is the shorter version. I could do it this way. Some students get confused with that, and so if you write out every single step, sometimes that helps to eliminate any mistakes. So I'm going to pull out all of my pairs. Okay, so up here I'm going to end up with 1, 2, 3, 4, 5, 6 3s. One x, and then there is an x left over. Okay, so let's see what this comes out to. We have 3 times 3 is 9. 3 times 3 is 9. 3 times 3 is 9, which is what we came out with down here, right? 9 cubed. So it is 729x square root of x as your final answer. Okay, what I'm going to do is I'm going to explain this a little bit better. And so I'm going to pull over another sheet of paper here, and not that one. Okay, in our square root symbol, we had 81 cubed, okay? So I'm just going to factor out 81 one time. Okay, now we have a square root, so we are trying to find groups of 2. So I circle my 2 groups of 2. Okay, I have 2 groups of 3, which gives me 9. Okay, so 9 is if 81 were by itself without the 3. But since 81 is being raised to the 3rd power, then we can raise this to the 3rd power. And we get 9 times 9 times 9. 9 times 9 is 81. 81 times 9 is 729. So that is another way of doing it. The only time that it gets confusing is if, say, you had an extra 3 here for whatever reason, your number was different. And then what you would do with this extra 3, sometimes that gets a little bit confusing. So, But if you have even groups like that where all the numbers are grouped up, like in this example, then this would be just a shortened way of being able to do this. All right, let's do our very last example here. Okay, we have 25 raised to the power of 4/3, and we have y raised to the power of 4/3. And that becomes 25 to the 4th power, y to the 4th power with an index of 3. Okay, so I'm going to factor out 25. And I get 5 times 5. Notice in this one, it's not like the previous one we just did. I don't have a group of 3. So in this example, I would go ahead and write everything out. So I have a group of 5 here. So that means that I would have 4 groups of 2 5s. So here's my first group, my second group, my third group, and my 4th group. And then I have 4 y's. Okay, oops, I went over into the other piece of paper. Hold on a second. I gotta put another y there. Sometimes I'm gonna squeeze a y right there. Okay, now I'm going to circle my groups of 3. So I have one group of 3, another group of 3, and then here's a group of 3. Okay, so 2 5s and a y go on the outside. And then on the inside, I have 2 5s and a y. Oh, the same thing. Okay, so I can simplify that to 25y cubed root of 25y. There is my final answer. Okay, that is all for today. If you have any questions, please email me. And I look forward to seeing you guys at our next Zoom meeting. All right, bye.